Hello friends, welcome to my YouTube channel. My today topic is acids. So in today's class we will learn the definition of an acid, what is the basicity of an acid, how can be acid classified, preparation of acid and the uses of different acids. So first, the word acid came from the Latin word acidus, meaning sour. The fruits and vegetables which taste sour contain acids. So the definition of an acid: acid dissolves in water and produce the H plus ion as the only cationic species, and this H plus ion is not so stable and reacts with the water molecule to form the hydronium ion, which is very stable due to hydrogen bonding. What are the properties of acids? Normally acids, mineral acids, are colorless, but sulfuric acid may look yellow due to impurities. The next, taste. Acids are sour in taste. Solubility. Acids are water soluble. So acids can be divided into two categories on the basis of their sources. The first is the organic acid and the second is the inorganic acid. Organic acids are mostly weak acids, for example acetic acid and oxalic acid. Why they are weak acid? Because they produce less number of H plus ions. For example, acetic acid, if we take 100 molecules of acetic acid molecule, only 10 or 5 molecules will get dissociated. Most of the molecules remain undissociated. Whereas in inorganic acid are example of HCl, H2SO4, HNO3, H2CO3. Normally inorganic acids are very strong acids, but there is one exception which is called the carbonic acid. It being an inorganic acid, it is weak. Inorganic acid also can be called as mineral acid because they are obtained from the minerals found at the earth's crust. And the organic acid, as the name suggests, they are derived from the natural source. So what are the definition of strong acids? Strong acids produce more number of H plus ions. If we take 100 molecules of HCl, total 100 molecules will get dissociated to form H plus ions. On the basis of concentration, acids can be divided into two subcategories: concentrate acid and the dilute acid. What is the concentrate acid? Containing more amount of acid and less amount of water. And the dilute acid is the reverse, containing less amount of acid and more amount of water. Basicity of an acid. The basicity of an acid is the number of ionizable H plus ions per molecule of acid. On the basis of basicity, the acids can be divided into three parts: monobasic, which has only one replaceable H plus; dibasic, which has two replaceable H plus; and the tribasic, which has three replaceable H plus. The monobasic acids are HCl, HNO3, HBr. Dibasic acids are H2SO4 and oxalic acid. Tribasic acids are phosphoric acid. So now the confusion is formic acid a dibasic acid because it contains two hydrogens? But in the definition I have said that only ionizable H plus will be count. So in spite there are two hydrogens, one is this one and the other is this one, but only this hydrogen will be dissociated because it is attached to the more electronegative atom oxygen. Similarly, H3PO2, this is called the phosphorus acid. This also acts as monobasic acid. Now the preparation of acid. How can acid be prepared? So the first step, the first process is by direct addition of non-metal with hydrogen. For example, Cl2, Br2. These non-metals react with the hydrogen and produce the gaseous HCl or gaseous hydrogen or any other hydrogen halide, they dissolve in water and produce the acid. So this kind of preparation is also possible. The second is from non-metals. So the non-metal is oxidized to the oxides, and these oxides will react with water to form the acid. If these oxides produce acids, they will be called as acidic oxide. If they are not soluble in water, they will be called as normal oxides. So what are the reactions of acids? The first, the reaction with metals. So if we react with the metal with the acid, such as sulfuric acid, hydrogen gas will be liberated. Same here, magnesium, which is a metal, alkaline earth metal, which reacts with the HCl, and the formation of MgCl2, a salt, and the hydrogen. Reaction with metal oxides, zinc oxide, H2SO4, ZnSO4 plus H2O. Calcium oxide, which is also a metal oxide, reacts with the nitric acid to produce calcium nitrate and the water. Now reaction with metal carbonate, this is a kind of neutralization reaction, but accompanied by the release of CO2 gas. For example, calcium carbonate and HCl forms the calcium chloride as salt plus water, and CO2 gas is also released. And why this is called a kind of neutralization reaction? Because in the neutralization reaction, an acid and a base react and produce salt and water. So here is the same reaction. It is an acid, it may be considering as a base, forms a salt and water, and in addition CO2 gas is released. So this is a kind of neutralization reaction. Now the uses of acids. So how can acid be used in our day-to-day lives? First, hydrochloric acid uses cleaning metal surface before galvanizing, and the properties exploited in this use is reaction of acids with metal oxides coating. Next, the sulfuric acid, it is used in car batteries. Properties associated is electrolytic behavior. Now the nitric acid, which is used in explosives like TNT and TNG. Phosphoric acid is used in fertilizers. Basically they are essential nutrients for plants. Acetic acid, additive in foodstuffs, preservative action and sour taste. Tartaric acid, baking powder, neutralization reaction. Indicators, these two indicators can be used to characterize the HCl solution. One is the litmus and the second is the phenolphthalein. The blue litmus paper turns into red in acidic solution, but the phenolphthalein is colorless in acidic solution. So here the chapter acid finished. Thank you.